What I wanted to do is just kind of summarize what we've been working on in class over the last couple of periods. And we've been focusing on looking at functions and using data that we might get from an experiment to make predictions and use it to write functions. So we have been kind of looking at graphs and graphing and reviewing some of those kind of concepts. But if we go back to earlier this week, we started off looking at using a cell phone and charging a cell phone as a way to collect data to then plot on a graph, making a scatter plot, and then sketching a line of best fit, and basically estimating a line of best fit for that data. Then we kind of moved on to using a calculator to figure out the line of best fit, and that's called a linear regression. So that's what we did on Wednesday and Thursday. Where's that? It's right here. And we use vocabulary, linear regression, extrapolation, and correlation coefficient, which is a way of kind of measuring how closely your regression line is to your actual data. And one of the examples that we did in class, we set up a graph that looks kind of like this. We set up a scatter plot. I gave the directions in class for how to use this on the TI-83. So when we set up a scatter plot underneath the stat function, that gives us the ability to then go ahead and graph it once you turn on your plot. And then after that, you can go back and do a regression. So the calculator figures out what would be a line that would best characterize the data in the scatter plot. In this case, it's in the form y equals ax plus b, where a would be the slope of that line and b would be the y-intercept. But then there's these other two numbers underneath, r squared and r, and we're looking at r as the correlation coefficient. So this is 0.93. It's pretty close to 1, so the data is pretty close to the linear regression. If you look at the graph, you can kind of see that it's very, very similar. It follows the same pattern, same direction as the line. Where something that might have a value that's lower than 0.9, maybe 0.7 or 0.6, the scatter plot would be much farther away from the line. So that's kind of where what we're working on right now, using data to model relationships and using functions to model relationships and trying to bring in a real world sense of solving problems.